Okay, guys, we are at Go Math, lesson 10.7, and we are moving beyond polygons into composite figures. So, poly means many. Polygon is a many-sided figure. A composite is a blending of two or more things. In this case, objects. So, for example, if I had something that was a rectangle that had a height of 4 and a width of 2, and off of that rectangle I had a triangle, and that triangle had a height of 5, and then off of that I'm going to build myself a nice little trapezoid here just to make it interesting, and I'm going to give that a height of 3 and a height over here of 2. Okay? So what I end up with is a really kind of an odd shape, right? And maybe this is a cardboard rocket ship that Mr. W is making because at the end of the day, sometimes nothing beats sitting at home playing in a make-believe rocket ship with my kids. So I end up with 3 distinct figures that I can solve here. I have a parallelogram, I have a trapezoid, and I have a triangle. So what I'm going to do at this point is just like we did with the polygons where we broke that up into shapes that we could recognize and solve, we're going to do the same thing here. But realize that we're going to need to make some connections between the multiple pieces of this composite figure to solve for all of the areas. So really when I break this up, I have 3 formulas, and I'm going to come over here and solve them. So I have a triangle. Area of a triangle is equal to 1/2 length times width. I have the area of a parallelogram, and that's equal to length times width. And I have the area of a trapezoid, and I'm going to call that TRA just so it's distinct. And area equals 1/2 base 1 plus base 2 times the height, maybe. All right? So what I'm going to do is I'm going to, in my mind, and I'm going to show you here for the sake of the video, I'm going to break this up into 3 distinct things. So the first one is my triangle. I have a triangle that has a height of 5. What is the base? It's not listed here, but I know that this is a parallelogram. So if this is 2, that must also be 2, just as this must also be 4, right? It's a rectangle. That makes sense. So I end up with this shape. Over here I have then a parallelogram, which is 4 by 2, and I end up with, I'm going to draw this right side up just for the sake of paying attention here, a trapezoid here with a base of 4, a height of 3, and another top of 2. So now I have 3 different shapes that I can solve, and then I'm going to put those shapes together to make the area of this whole object here, right, this whole shape. So the first one is my triangle, and I'm going to come over here to this side of the board, and I have area of a triangle 1/2 times 2 times 5. 1/2 times 2 is 1 times 5. The area of my triangle equals 5. The area of my parallelogram is 4 times 2, and that makes that 8. Area of my parallelogram equals 8. So I'm starting with the formula. I'm plugging in what I know, and then I'm able to solve it. Down here, the area of my trapezoid is 1/2 times 4 plus 2, base 1 plus base 2, the bottom plus the top, times 3. 1/2 times 4 times 3, that's 1/2 times 6 times 3. That's 3 times 3. So the area, and I'm going to come over here just so you can see it, area of my trapezoid equals 3 times 3, or 9. All right, so then what I end up with is 3 distinct areas of 5, 8, and 9. 5, 8, and 9. So this is 8, this is 5, and this is 9. So I add them all together. 5 plus 8 is 13. 13 plus 9 is 22. 22 units squared. And that's my whole area of this composite figure. You might say, well, Mr. W, this is a really long, complex problem, but it's not. It's actually 3 very simple problems, just looked at a little bit differently. So let's back up and take a look in your book. What I end up here is a composite figure, let me move this over here, composite figure that's made up of a triangle, a trapezoid, and a parallelogram. Look familiar? It should. First thing that I'm going to do is I'm going to identify the formulas that I need. A triangle, a parallelogram, and a trapezoid. Area of a triangle is 1/2 base times height, or length times width. Area of the parallelogram equals length times width, or base times height. I'm going to make them all length times width for continuity's sake. And area of the trapezoid is 1/2 base 1 plus base 2 times width. Now, again, if you don't know these formulas, we need to go back and do some reviewing because they're all essentially the same formula. I'm just looking at pieces of the parallelogram. Once I understand those pieces, I can solve it. So starting with my triangle, I don't have a full length. They're trying to trick you here. So what I end up having, I need to go off of this section. So most people might say, well, 16 would be my length and 20 would be my height, but 20 is actually what we call your hypotenuse. Instead, I realized that 12 is the height. So 1/2 times 16 times 12, that's 8 times 12. 8 times 12 is 96. So 96 centimeters squared. That's my triangle. I've got it. Over here, this is 12 times 12. This right here is my parallelogram. 12 times 12 is 144 centimeters squared. And then my trapezoid, I don't have a bottom for my trapezoid. I don't have a base 1. But I do down here because I know that if this bottom one is 12 centimeters, so is this top one. So I end up with 1/2 times 12 plus 9 times 6. Base 1 plus base 2 times the height. Okay? 1/2 times 21 times 6, or 21 times 3, which ends up with 63 centimeters squared. All right, so now I have the area of all three of these objects. I have 63, I have 144, and I have 96. So I'm going to add them all together. 96, 144, and 63. Add them together to get my full composite figure. So I've solved each shape on their own, and then I'm going to add them together. And this becomes 13, that becomes 20, 303. So my overall 303 centimeters squared. There's my overall completed area because I solved for the area of my triangle, and I made sure that I knew which measurements I was using correctly. Area of my triangle, area of my parallelogram, and the area of my trapezoid. I solved them all separately using the formulas, starting with the formulas, plugging in what you know, and then solving them. And again, ladies and gentlemen, you're not doing this in your head. So you must, I absolutely must insist, you pick up a pencil and you write out your work. Okay, so go back and check your work. Solve for each individual one, then add them together to get the area of your composite.